Good afternoon and warm welcome everyone to this webinar on good licensing practices for protected elements in OECD test guidelines. My name is Anne Gourmelon and I am overseeing the OECD test guidelines program. I'll introduce this webinar today and the work done at OECD. And following my talk, our two speakers for today will continue with further explanations. We'll hear from Dr. Sharon Baya, who works at the European Collection of Authenticated Cell Cultures at Public Health England in the UK, on important aspects of intellectual property and protected material used in vitro assays. And next, we'll hear a talk from Karolina Gutmostovi from the IP and Technology Transfer Unit at the Joint Research Centre, European Commission in Brussels, on the terms and conditions for FRAND licenses. I'll give an introduction to this webinar to set the scene and set the context of this webinar. So first, what are OECD test guidelines? So we are talking about harmonized test methods for chemicals, pesticides, biocides, nanomaterial safety testing. These OECD test guidelines encompass a collection of 5 series regrouped by topic. And we have currently more than 160 OECD test guidelines. They are developed and adopted by OECD countries and adhering countries to the system of mutual acceptance of data. These test guidelines are continuously updated and augmented to keep pace with progress in science and animal welfare and economic considerations. So why are we having this webinar today, and why is innovation important at OECD in the test guidelines? We've seen and we are seeing today chemical safety policies in member countries evolving. In particular, there are numerous ethical issues with animal testing. And to overcome what could be an obstacle to innovation and further updates of OECD test guidelines, we are also seeing that innovative techniques today can generate very useful data that can be used as alternatives progressively to animal testing. But this innovation comes with a cost, and innovation needs protection. So for OECD test guidelines to integrate innovation, regulators need transparency in addition to this innovation. So what we are doing in the test guidelines program is that we are trying to resolve this duality between the need to integrate innovation and the need to maintain transparency for the decision makers to protect human health and the environment. I'll continue talking briefly about what we are doing more specifically to integrate innovation in the test guidelines program. And as many of you in attendance today may be themselves innovators and test method developers, I'm going to touch a little bit on what you need to provide when starting a new project at the OECD to your proposing country who is potentially going to lead the activity to develop a new test guideline. It's very important to identify correctly the protected elements. When submitting a project proposal at the OECD, we have a template format that needs to be filled with relevant information from the test developer. So what are we talking about? We are talking about the nature of these protected elements. It's very important from the onset to identify exactly what is protected. Is it a cell line, a DNA construct, an algorithm, a reagent? Is it a test medium or a data set? Or is it a combination of different elements? It is also important to be very clear from the start on the form of protection. Is there a patent on the identified elements? Where is that patent available? Is it a trade name or is it a copyright on the software? This needs to be clear from the start, because protection of innovation is generally accepted in the OECD test guidelines program, but trade secrets are not for transparency reasons. And then also, as test developers, you will need to make sure that the IP right holder is correctly identified, and because test developers are not always those who have these IP rights, and the test developer should have obtained permission to use protected elements from the IP right holder. Sharon will talk in more details about these topics in her presentation next. I'll briefly touch upon the conditions and availability of protected elements to the end users. And by end users, we mean the contract research organizations who will use the regulatory test, the test guideline, when it is available. They need to know where are these protected elements available, and is it from a quality controlled source and sustainable source, and by which means they will be able to access these protected elements. Is it by a material transfer agreement or will they have to sign a license? This is also very important to understand clearly from the start. And finally, I wanted to mention that the reason why we are having this webinar today is also to promote an OECD document that was published in 2019, and you have the reference in front of you. The document is about the guiding principles on good practices for the availability and distribution of protected elements in OECD test guidelines. And in particular, this guidance document is explaining and promoting what we call fair, reasonable, and non-discriminatory terms and conditions when licensing protected elements. So when submitting a proposal to the OECD, test developers will be asked if there are protected elements in the method to sign a declaration that they will offer the test or the protected elements under these FRAND terms and conditions to all potential users. And Carolina will talk in more details about these FRAND terms and conditions.
Thank you, Anne, for the introduction. The presentation that I will be giving today will cover the role of biological resource centers in retaining traceability and authenticity of cell lines, with particular reference to their use in the development of test guidelines. We will cover two key aspects which relates to the biological importance of assessing the identity of a cell line, which is being used in the development of a test guideline. We will also look at the importance of gaining some commercial use assurances when you're developing a test guideline using a specific cell line. To start with a very brief overview of the role of biological resource centers, specifically focusing on those like ourselves at ECAC who are distributors of cell lines. We generally curate, maintain, and distribute authenticated biological material. And in our case, we're specifically talking about in vitro use cell lines. There are a number of international cell banks, and some of those are also recognized as depository authorities for the purposes of patterning under the Budapest Treaty. And the key remit that we all share is that we want to and wish to promote good cell banking practice, and with a very strict emphasis on quality control. Because it is critically important that the cell lines used in all types of research are authentic, and it's important that we utilize the quality control process to ensure that these cell lines are free of contamination, but also to verify that the cell line is indeed the correct cell line, so it's derived from the original donor material, and it's maintained that continuity throughout its development pathway. Each cell bank generally operates to these good guiding principles, but we do operate independently. And we do very much view ourselves as the custodians of the collections. The cell lines are provided to us by usually the originators, who we refer to as depositors of the cell line. And it is their choice whether they wish to deposit a cell line into a single cell bank, or whether they wish to share it amongst multiple cell banks worldwide. And likewise, it is entirely in their control, or their funding body's control, with regards to how they would like to allow others to access those lines. So we are looking at issues that we will touch on later about the availability for the use of the line for research use only, or potentially for commercial use as well. Now, one of the critical aspects when considering utilizing a cell line for the development of a test guideline is to ensure that the cell line identity is correct. And the process that we use for this is termed authentication testing. So authentication ensures that the cell line being used matches the donor material from which it was originally derived. And if the two materials do not match, then we will term that cell line to be misidentified. Now, some of the leading causes of misidentified cell lines are cross-contamination of different cell lines. So this is when you are culturing a specific cell line for use, and somehow inadvertently through that culturing process, you introduce a secondary cell line. So what then happens is you can either get a co-culture where you've got two different cell lines culturing together, and in some cases, the second contaminant cell line can over-dominate the culture, and without a researcher realizing, that culture can transform from cell line A to cell line B, which then has a number of downstream effects with regards to the validity of results generated using that in vitro model. And also, it can affect the reproducibility of those results when other researchers from other institutes try to replicate that work. Another potential cause that we see is because of labeling errors, wherein the ID tags placed on the vials in which the cell lines are stored get mixed up, or the wrong information is placed on the label, and therefore inadvertently the wrong cell line is utilized for the development of an experiment. One key way in which researchers can minimize the adverse effects of utilizing misidentified cell lines is to source their cell lines from a reputable cell bank. Rather than reaching out to perhaps collaborators, or sometimes cell stocks are available within the research institute, but there may have been there for a number of years, and therefore there may not be full documentation regarding their development and use and propagation, to ensure that there are no potential queries with regard to identity of a cell line. If you source a cell line from a cell bank, you can be assured you are getting a fully quality control authenticated cell line. To gain an understanding of the potential effects of utilizing misidentified cell lines in research, I'd like to bring your attention to an article here, which features Christopher Koch, who is one of the founding members of the International Cell Line Authentication Committee. The article here looks at the citations of two popular human cell lines. One is HEP2, which is frequently used as a model for laryngeal cancer, and the other cell line is INT407, which is often used as a model for intestinal cells. Now, both of these cell lines are in fact derivatives of the HeLa cell line, which is a very popular cell line which was derived from cervical cancer cells. And the video here that you can see on the screen just highlights just how quickly HeLa cells can dominate a culture when they are introduced as a contaminant. The HeLa cells there are highlighted in red. And as you can see, with each population doubling, the HeLa cells quickly start to outnumber the original cell culture. The knock-on effect of the use of these two cell lines here, HEP2 and INT417, is quite significant with regards to the number of articles which are published each over the space of the last 10 years. And we're looking at the number of articles published using the cell lines as a primary model directly in the research being published. And the knock-on effect of that is essentially that $713 million worth of grant funding and research funding has been used where the model is described as either a laryngeal or an intestinal model, but actually these cell lines are cervical in nature, and therefore the model may potentially be inappropriate. And the knock-on effect is that those original papers then have been subsequently cited, and that knock-on effect of funding spent on potentially misidentified research here is $3.5 billion. So it's quite a significant effect when you start taking this into account. So following on from some of the underlying theory and of the importance of authentication testing and what can happen when cross-contaminated or misidentified cells are used, I wanted to bring your attention to an issue which directly relates to a published test guideline. And this is test guideline number 455. The background here is that estrogenic endocrine disrupting chemicals are often found in a number of sources, including environmental and biological samples, as well as consumer products. And they can potentially have adverse effects. And this test guideline details a method which can be used to screen for these compounds. The cell lines used in this assay express estrogen receptors, and the cell line has been stably transfected with a estrogen receptor responsive luciferase reporter gene, which allows chemicals to be identified that can either activate or suppress the estrogen receptor. The general chemistry behind this test assay is that when a ligand binds to the estrogen receptor, that dual receptor ligand complex will bind to that specific DNA response element and activate a reporter gene. And in this case, the assay system will transform the substrate into a bioluminescent product that can be quantitatively measured. This test guideline is approved by the OECD, but the assay has also been approved by the US Environmental Protection Agency as a bioanalytical method to detect estrogen receptor agonists and antagonists. The fundamental basis of the assay utilizes a derivative of the BG1 cell line, which is known to be a human ovarian adenocarcinoma cell line. And as previously mentioned, a luciferase reporter gene has been transfected into this cell line, and this new cell line was then termed the BG1 luciferase 4E2 cell line. The guideline was published, and the assay was put into use. However, afterwards, a paper by Li et al. Reported that actually, within the research community, there were two variants of the original parental BG1 line that existed. The one variant, BG1FR, was deemed to be a unique cell line in its own right, whereas the BG1NIEHS variant was actually termed to be a variant of another very popular cell line, the MCF7, which is the human breast cancer cell line. And unfortunately, it was deduced that it had been the MCF7 variant which had been used to develop the test guideline and not the original BG1 cell line, as had previously been thought. So what was the outcome of this? Now, luckily, the effect of the estrogen receptor binding and the activation of the luciferase assay was unaffected by the basal change in the cell line. So the fact that it was an MCF7 basis for the assay rather than the BG1 basis, luckily, did not affect the outcome of the assay and the test that was being undertaken, which was to detect estrogenic and anti-estrogenic compounds. As a consequence of the data that came to light after the assay had been authorized for use, the naming of the cell line was changed. So what was originally referred to as the BG1 luciferase cell line was then named the VM7 luciferase cell line. with the V and the M7 being a reference that this cell line is a variant of the MCF7 cell line. And the guideline was republished with the edit added on, and the link there will take you straight through to the guideline. So one of the key things to take note here of is whilst use of misidentified cell lines can cause issues, it does not necessarily immediately invalidate the data, but it may require you to revisit the data and to reassess your conclusions and your summaries that you obtain from that data. And this follows on to the second case study I'd like to bring to your attention, which relates to the in vitro Bas42 cell transformation assay. Now, this is used as in the assessment of the carcinogenic potential of chemicals. And the method uses a type of cell line model where, to some extent, the multi-stage cell transformation process that happens when normal cells transform into cancer cells can be mimicked. And generally in the research community, the Bas42 cells previously have always been deemed to be a good model of an initiated cell and a specific tool to study the promotion stage in a multi-step carcinogenesis process. Now, Bas2 was believed to have been derived from the bulb-C mouse strain. However, in 2017, research was published which showed that actually the line was derived from a Swiss albino mouse rather than a bulb-C mouse. Now here, the knock-on effect is that research has previously showed that the two different strains of mice have differences in their susceptibility to various chemicals and viral infections. And therefore, the basal understanding of the mechanisms relating to cancer development using Bas42 as a cell model are now being questioned. And again, it's not necessarily looking to say that all the data is invalid. The consensus seems to be now that whereas this model was previously thought to be a good model for the early stage progression of cancer, it's now perhaps a better model for late stage modeling of carcinogenesis rather than early stage. So again, potentially we have an issue here where a cell line was used in a way that at the time was thought to be appropriate for the model being displayed. As data has shown that the cell line was actually derived from a different mouse strain, it's affected the mechanistic understanding of what happens within that in vitro cell model. And consequently, whilst the original justifications may no longer be valid, it is possible that the model can still be used, albeit for a slightly different endpoint. So those two case studies covered some of the biological aspects which relate to the use of cell lines and why it's important to ensure that we have confidence in the identity of the cell lines which are being used for test guidelines. And that's where cell banks can help researchers. But I wanted to follow on now to look at some of the issues that we experience downstream once test guidelines have been published. And this now relates more to access to the actual cell line and the release conditions associated with various cell lines. So generally in cell banks, as I stated, we are generally seen as curators and custodians of the collections, and the release conditions on each cell line are dictated to us by the depositors of the cell line. And broadly speaking, we can break this down into a number of categories. So we have cell lines within the collection which are available for research use quite easily. There are no licenses or material transfer agreements that need to be signed, and all researchers, regardless of whichever organization they work for, are able to easily obtain the material for internal research use only. Some of these items have a second layer of restriction on them, wherein if a researcher from a commercial organization wishes to use the line for research use, they have to require a license agreement from the depositor who holds the use rights. But again, those licenses tend to limit them to internal research use. Often, when a cell line is to be used commercially, that is, it's to be used to generate income by an organization, or if sometimes it is used in a not-for-profit organization, but the work is funded by a commercial organization who wish to utilize that data in a commercial setting, then often in those cases, a commercial use license is required for use of the cell line by the researcher. And then we have kind of a third category of restriction where, in some rare occasions, depositors will not release their cell line for use until they approve each and every application. And this can be for both research and commercial use. And unfortunately, there are some cell lines within our collection and in other collections worldwide where it's just not possible to allow commercial entities to utilize the cell lines for either research or commercial use. And sometimes that is aggravated by the fact that the depositor who originally provided the cell line can no longer be contacted. So where does this create an issue with regards to the use of cell lines in test guidelines? So what we have seen previously is that test guidelines, especially when they're being developed in organizations who are classified as either academic institutes or not-for-profit organizations, researchers in these organizations can easily acquire access to the cell lines. So they'll be able to bring the cell lines into the laboratory and they'll be able to utilize them to start developing a test guideline. And all being well, if that test guideline is then published, it's often at this stage that commercial entities will need to utilize the cell line. And that then triggers the need for a commercial use license. So this could be whether an organization wishes to use the assay in-house as part of their own product development pipeline, or it could be an organization like a contract research organization who wish to utilize the assay to provide the test guideline as a service for third-party clients. Now, unfortunately, the hiccup here comes that sometimes when that commercial entity who wishes to utilize the test guideline and therefore wants to acquire access to the cell line for commercial use contacts the cell bank for permission, when we sometimes have to revert back to the depositor, some of these cell lines have been deposited into our collection many, many years ago, and we sometimes have difficulty contacting the depositor. And if we have not had clear guidance initially from the depositor with regards to what licenses or commercial uses can be permitted on the line, if we cannot gain that reassurance, we unfortunately cannot allow the commercial entity to utilize that cell line for the test guideline, especially when they're providing it as a service. Likewise, we've seen the other effect wherein the cell line depositor can be contacted, but because the cell line is proposed to be used by a commercial entity in a commercial manner, the depositor then charges a license fee for access and use of the cell line. And sometimes the license fee can be quite excessive, and the commercial organization wishing to utilize the cell line cannot justify the costs. Now, the adverse effect here is that if this happens, the test guideline cannot be utilized, and that is not a good position for any of us to be in. So what we'd like to promote is to researchers out there who are in the process of developing test guidelines or who wish to propose new test guidelines in the future, is at the very initial stage of your application process of when you are proposing the development assay, is to engage with the cell banks from whom you should be acquiring your cell lines and clarify any potential restrictions that may affect the downstream use of that cell line. This is especially important for researchers who are from not-for-profit and academic institutions. Quite often, your access to the cell line will be unquestioned, and you may go on to develop a test guideline, which, if approved, could be dependent on the use of a restricted cell line. However, if you engage with the cell banks at the very early stage, you'll be able to acquire information with regards to whether this is a feasible line for you to use. And if it is, but there may potentially be commercial use licenses imposed on the line downstream, then there's always the potential to set up an agreement for the use of the cell line for OECD specific work downstream. What we don't want is any investment into development of test guidelines which then cannot be utilized because of commercial use restrictions. Likewise, we also do not want the development of test guidelines wherein the material used, which is central to the output of the assay, is later known to be misidentified, which invalidates the assay. Thank you all for listening. I would like to also thank Dr. Miriam Jacobs, the UK National Coordinator of the Test Guidelines Programmes, for all of her support and help in producing this presentation.
Thank you very much, Sharon, for this presentation. And we will take questions via the chat box eventually at the end of this webinar. So please, now let me introduce Karolina Gutmostovi, who is going to give her talk. Karolina, floor is yours.
Thank you very much, Anne. Good afternoon, everyone. My name is Karolina Gutmostovi. I'm a legal officer at the Joint Research Center at the European Commission in Brussels. And I helped to draft guiding principles on the good practices elements in OECD test guidelines. I was one of the authors of the part on licensing of protected elements. And as such, I would like to talk today to cover three blocks, three topics with respect to distribution of protected elements. First, we are going to have a look at what are protected elements in the OECD test guidelines in general. After that, we will see why they need to be made available and what are FRAND licensing terms, and how in practice this should be done from the perspective of the rules at the OECD test guidelines. Okay, so let's move to the first topic. What are the protected elements? In general, a protected element can be any feature or aspect of a test method which is protected by intellectual property rights. So we talk here about elements that are protected by IP in a way that such elements cannot be used without the consent of the holder of the IP rights. So for example, we can find protected elements in methods for measuring biological markers. We can find protected elements in cell lines or tissue models that are used in test methods. We can find protected elements in devices and instruments used for the test, and which is very common as well, we can find protected elements in computer software, computer algorithms, which are used for the interpretation of the data coming from the test method. A test method can be protected in various ways by intellectual property rights. Just to give you a couple of examples, the one that is quite important is patents. Patents provide protection for technical inventions. So that would be all kinds of products, processes, apparatuses, and uses. For example, that can be the process of performing a test. The whole process might be protected by a patent. And in some jurisdictions also, a computer software used for the test can be protected by a patent. For example, in Europe, this applies when the computer software has a technical effect associated with the device. Another way of how IP comes into play in terms of test methods is registered and unregistered designs. They provide protection for the shape of objects. So for example, some of the devices that are not protected by patents may be still covered by registered or unregistered designs. Another method is trademarks. Trademarks may cover the names of the test or the logo of the producer or the laboratory. And then copyright, which is widely used as well in this field. Copyright provides protection for computer programs and software in the cases where this protection is not granted by patents, but also copyright covers websites, all kinds of written artistic works. Lastly, database rights that provide protection for collections and compilations of data. So it's important to remember that some of those rights need to be registered to be created. For example, patents require registration, trademarks require registration, but some other rights, for example, copyright, do not need any registration to be enforceable and to be binding. Now let's look at the access to protected elements. First of all, why do we need access to protected elements in the OECD test guidelines program? Well, it was already mentioned by Anne in the introduction. One of the rules of the program is that it needs to be accessible and transparent. Therefore, the whole documentation establishing the validity of the test is made available for review before the method may gain acceptance. Furthermore, if the test method contains protected elements, so the IP rights that I described before, the developer of the method is required to be transparent and needs to indicate at the very early stage, so at the stage of initial proposal, it needs to be indicated what kind of protected elements are there and what is the access to those elements, but we'll get to that. So most definitely the OECD test guideline programs is not against the protection of intellectual property. Protection of intellectual property is encouraged. And the only, I would say, caveat is that IP needs to be made open, needs to be made available, and needs to be disclosed, not in a sense of unlimited access, but in the sense of information about the IP. But we will get to that in a bit. Okay, so how do we access protected elements? Basically, since there's an owner of an intellectual property right and the person wants to access them, the easiest way is to conduct an agreement. That would be either a material transfer agreement or a license agreement that is also very popular in the field, or if the protected elements are covered by patents, then also one of the ways of accessing might be creation of a patent. Access to protected elements should be on FRAND terms. So now let's move to what exactly is FRAND terms. Reasonable and non-discriminatory, so RAND terms, are known in the European Union as fair, reasonable, and non-discriminatory terms, FRAND. FRAND is basically a voluntary licensing commitment, which is given from the owner of an intellectual property right that participates in a standard setting organization, in this case, the OECD, in a case that the intellectual property right might become essential to a technical standard. The principle of FRAND licensing is very well known and is very well established in other fields where technical standards are popular. So, for example, in the field of mobile telecommunication industry, there are many standard essential patents utilized, and access to those patents is granted on FRAND terms. But also in other types of standard setter organizations, every time there is a need to access intellectual property, FRAND licensing is, I would say, the most popular way of constructing the license agreement. So why is FRAND important, and what are the advantages of FRAND licensing? So on one hand, for the user of the intellectual property, so for the licensee, FRAND allows to access the IP. So that in that sense, the user also benefits from the standard set by the standard setting organization. FRAND also prevents the IP owner from refusing to give access to the technology, or let's say grant access only under unfair or unreasonable licensing conditions. And lastly, from the perspective of the user of IP, FRAND also contributes to further dissemination of the standard. From the perspective of the IP rights owner, under FRAND, the holder of the IP rights is sure to receive royalties that compensate the added value to the standard. And also those royalties should be adequate to what have been actually spent on research and development. In that way, FRAND allows recuperation of the investment in R&D and gives a further incentive to invest in intellectual property. Now let's move to the description of FRAND in the OECD test guidelines. let's see how those conditions are phrased in the document itself. So the main concept of FRAND, which has been, I would say, the inspiration to include in the OECD test guidelines, is that the parties to the licensing agreement, they know the best what FRAND is, meaning that they engage in good faith negotiations with a view of establishing conditions that are fair, reasonable, and non-discriminatory. But at the same time, the parties are the ones that are in the best position to decide and establish what FRAND is in a specific situation. FRAND is also not a one-size-fits-all solution. It's not, FRAND is not a particular rate or a percentage of royalties. FRAND, let's say, I would say it's a range, and FRAND is also more of a idea that when negotiating the licensing fee, the fair, reasonable, and non-discriminatory conditions should be applied. But indeed, we managed to include in the guiding document, we managed to include some principles which should help to come up with a royalty rate that will be indeed FRAND. So first of all, the fair and reasonable part of FRAND refers mainly to the licensing rate, right? So this is the rate that is charged to the licensees. This rate should not increase the cost for the licensees up to the level that is uncompetitive or unreasonable, but at the same time, this licensing rate should provide a compensation for the licensor, so for the holder of intellectual property rights, and should also provide an incentive to continue investing and contributing to the standard in the future. The non-discriminatory part of FRAND relates both to the terms of the license agreement, but also to the rates included in the license agreement. As FRAND may be different from sector to sector, it will depend on very much on a specific arrangement between the parties. Now let's look at some tips how to determine a FRAND value and what should be actually taken into account when coming up with the value of FRAND in a particular case. So first of all, FRAND value should reflect what is the value added by the protected element to the standard. So this is pretty much the value of the IP added to the standard, but in the context of OECD test guidelines, it should be irrespective of the market success of the product itself. In this approach, the value should not in principle include any element resulting from the decision to include the protected element into the test guideline. So in other words, the licensor should not be allowed to charge extra only for the fact that the protected element is becoming a part of the test guidelines. The situation might be slightly different when the protect element is developed only for the purpose of being included in the test guideline and actually has little or no market value outside of the test guideline program. In this case, we need to consider alternative evaluation methods. And in this case, it will be interesting to see what is the importance of the protected element in the test guidelines compared to all the other contributions to the guidelines. Now let's look briefly at what the not discriminatory element of FRAND means. In general, the non-discrimination between parties should be between parties that are similarly situated. Well, one can ask if actually not all participants to the test guideline programs are similarly situated. Well, I would say the answer is yes or no, because some of the participants might be big international companies, some of the participants might be small laboratories or just test developers. Therefore, in the view of the principles of the test guidelines program, there should not be created any unnecessary entry barriers for small enterprises or laboratories. That's why licensing conditions, which are FRAND, should not include large fees and upfront payment. Rather, what is expected is that the royalties will be based on actual turnover or the cost per test. So what is the bottom line of those principles? Basically, in the context of the OECD test guidelines, FRAND should be applied in order to ensure effective access to protected elements, and therefore a wide access to the test guideline, and therefore a further dissemination of the standard. FRAND commitment is compulsory in the OECD test guidelines program. It's included in Annex 2 to the guiding principles. And the participants wishing to have their protected elements including in the program, they need to provide this commitment in writing, that they will give access to all third parties and that they will license their protected elements on FRAND terms. This is a mandatory commitment. A lack of acceptance of this commitment may mean also that the protected element will not, or the test will not be included in the program. Thank you very much for this. I'm happy to take questions now. Thank you.
Thank you very much, Carolina and Sharon, for your presentations today. I hope everyone found the webinar presentations interesting and useful. So let me remind you maybe how to use the chat box. If you put the cursor at the bottom of your screen, you will see the Q&A icon. So we already have one question in the chat box. Another one is coming. Okay, maybe Sharon, do you want to take the first question regards ECOC?
Sure. So I will read the question out first. So the question is, do ECAC or other cell banks keep a list of the cell lines that are not available for commercial purpose? That is, they do not have donor consent. It would be useful for method developers to know upfront which cell lines to avoid. So absolutely, and I fully agree with that comment. So ourselves at ECAC, and I do know that other cell banks worldwide do also, on the catalogue page for each cell line, there will be a reference to whether a commercial use restriction is placed on the line. However, with some of our cell lines, which do not originally come with commercial use restrictions, it may be something that we have to look at in depth. So what I would encourage all researchers and all test method developers is to contact the cell bank from whom you are considering acquiring the cell line, and just clarify to them what your reason for obtaining the cell line is and what the downstream effect of that would be. And we can, as a cell bank, we can then help you ascertain whether those rights are in place at the very beginning, or whether we can work to acquire those rights as required. Thank you for the question.
Thank you, Sharon. We have another question in relation to FRAND, and FRAND is a great initiative, sincerely appreciated. Would there be royalties or one-time license fee, or both? Maybe Carolina, you could take this question if you wanted.
Yeah. Yes, sure, definitely. Thank you, and thank you for the question. Well, indeed, it could be both, or it could be neither. This FRAND, the idea of FRAND is that the scope of royalties is applicable in each case, let's say differently. It's adapted to the conditions, but the royalties still need to be fair, reasonable, and non-discriminatory. So I would say that probably royalties which are paid based on a turnover are more likely to be fair, whereas let's say big one-time payments are more likely to be considered unfair. But as I said in my presentation, this is something that is going to be this should be discussed between the parties and applied within the particular circumstances of a particular license agreement, right? But in general, as my private opinion, I would say rather it's more often that royalties as a monthly or yearly payments are considered to be FRAND than one-time upfront.
Thank you.
Hope this answers the question.
I guess you could take the next ones, or the next two ones, which are related to computer software and in silico tools, Carolina.
How FRAND would apply in silico tools? I'm a lawyer. I can only speak from the legal perspective. When it comes to the part of the question, I would say, is it allowed to refuse a license in certain conditions? Yes, definitely, it is allowed to refuse a license in certain conditions. It would be provided that such refusal is fair and reasonable and non-discriminatory, right? So here, Donna in her question says that previously bad debtor or a competitor. Well, I would say that this should be judged from the perspective of non-discrimination. So if we are, let's say, refusing a license based on the fact that someone has not previously has not been paying the royalties fees, this doesn't seem undiscriminatory to me. I would say that this is a justified, in business conditions, this is a justified reason to refuse a license. Therefore, I would say in theory that would be FRAND compliant, yes. But as I said, obviously, FRAND terms need to be judged on each situation separately.
Okay, yeah, thank you, Carolina. Maybe the next question I can try to answer. For computer software, what does transparency mean? A description of what the code is doing, access to the source code, or something else? Here, I'm afraid there's no simple answer, as we have not, in the OEC test guidelines program, have been exposed yet to these type of situations, but they are coming our way very quickly, and we will have to develop a policy and learn by doing. But basically, the regulators, what they really want is sufficient information so that they can understand what the system is doing. The system meaning maybe here the computer software, the software, and so it's not necessarily all the details and the source code, which are really maybe for the experts, but they want to be sure that the system is robust, the system is transparent, and that it is reliable, and it is doing what it is expected to do. So I won't enter into the details here, as you can imagine. There's a next question. Typically, the charges for the in vitro skin and eye irritation models are prices per unit used. Is this likely to change? Well, I guess, yeah. Carolina, you want to take that question?
Yes, just to say that from the perspective of FRAND, the type of license, the type of fees that is charged is not that actually relevant. It's not that relevant whether it's monthly or yearly. What is relevant is that it's fair, reasonable, and non-discriminatory. So if charging per unit is transparent, is reasonable, and is not discriminatory, and it fulfills those principles that I mentioned during the presentation, so that it reflects the actual price for the IP and includes a fair compensation for the IP holder. This can obviously be FRAND compliant as well. So what I mentioned before about monthly royalties and big one-time payments is that quite often it is suggested that just paying big amounts in one go instead of paying installments or paying royalties based on actual turnover, this is something that can be considered not fair, right? So the exact way of how we construct royalties is not decisive here. What is decisive is that the way that the royalties are phrased is not leading to discrimination or is not leading to unfair conditions for parties.
There's a next question. How is OECD controlling that the FRAND principles are respected? Well, OECD as an organization is not controlling. We are not a court. We don't have judges and at the OECD. But what I can say, though, is that when a test developer is required to sign a FRAND declaration, a signature is important. It's a commitment, I would say. And what would be the consequences if the FRAND terms were not observed would certainly be if this was known to the working group of the national coordinators of the test guidelines program. It could have consequences on the test guideline itself or on the ongoing project. And either the guideline could be cancelled if the situation is serious enough, or other responses, but it's certainly not something to encourage to sign and then do something different. I don't know if Carolina would like to add to that.
No, there is. Thank you, Anne. This is, I think, this fully answers this question indeed. And also, we operate. We use this FRAND licensing only within the, let's say, our program, right? So this applies to the parties that want to participate in test guidelines program. We are not going to control any other licensing agreement between participants and any other third parties, right? This is a purely, I would say, internal mechanism that works within the test guideline program.
Thank you, Carolina, and thank you, Sharon, for answering these questions. There were a couple more questions, but revolving around the same topics or otherwise entering into some specific cases. So maybe we will take these answers separately, or you can address them to the OECD, and we'll see how best to answer them. I wanted to let you know that this webinar will be available online in a couple of days, next week or soon anyway. So to replay the webinar in future, you can go to the website indicated here. This is the OECD website, and the presentations will be available, and the video of the webinar as well. So thank you very much to our panelists today, and thank you to the participants for your attendance, and keep safe and healthy in these times. Have a good day. Bye.